Hi, I'm Lucas, and you're listening to Gradient Descent. We started this program because we're super passionate about making machine learning work in the real world by any means necessary. And one of the things that we discovered in the process of building machine learning tools is that our users and our customers, they have a lot of information in their heads that's not publicly available. And a lot of people that we talk to ask us what other people are talking about and what other people are doing, what are the best practices. And so we wanted to make all the interesting conversations that we're having and all the interesting things that we're learning available for everyone out there. So I hope you enjoy this.
Today our guest is Rachael Tatman, who is a linguist and a developer advocate for Rasa, who helps developers build and deploy conversational applications using an open source framework. Before that, she was a data scientist at Kaggle, where she was also a Kaggle Grandmaster. She also did really interesting work at the University of Washington as part of her PhD in linguistics.
Yeah, thank you for having me.
Oh, my pleasure. The place where I was hoping to start, if it's all right, is kind of your experience at Kaggle, just because I think that's such an interesting website with so many interesting learnings about machine learning. I feel like a lot of kind of new stuff, it kind of happens on Kaggle first sometimes, and the insights that folks have are so interesting. Could you just maybe tell us a little bit about what your experience at Kaggle was like and kind of what you learned working there?
Yeah. So I was at Kaggle for 2.5 years. And I think most people who are familiar with Kaggle are familiar with the competitions, which are generally supervised machine learning competitions where everyone's working on the same problem with the same data set. And I never actually supported competitions directly. So I worked on the dataset hosting platform, and I worked on the hosted Jupyter Notebook environment that Kaggle develops, which is called Notebooks, Kaggle Notebooks at this point. It was called kernels for a while because you could also have scripts. And also the forums for developers to talk with each other, and the Learn content I also worked on a bit as well. So Learn is Kaggle's sort of machine learning courses. They're becoming more sort of structured and fully featured over time. So I worked on all those parts of the website. I worked a lot with the community, developing educational content, making product recommendations. So one of the things that I'm most proud of is I mentioned we had scripts that were sort of flat hosted Python or R files or R Markdown. And we also had notebooks. But for a while, if you had a module you're working on in a script, there was no way to use that module in a notebook. So I worked with the engineering team to sort of spec out what it would look like to have importable scripts. And now you can do that. It was built out and was, I think, pretty successful.
So was Kaggle your first kind of industry job coming out of a PhD?
It was. So I started right after I graduated. And I was actually, at the time, I was still applying for faculty positions as well. So I was in this sort of limbo where I was working at Kaggle, and I was also in the faculty job market for academic positions. And I found that I really enjoyed working in industry, and the things that I would have liked about a faculty position, so the teaching and helping people build cool things. My preference would have been more languagey things, which is why I'm at Rasa now. I had a lot more reach and impact at Kaggle than I would have had in a university setting. So I found that really appealing.
Were there any kind of things that you had to get used to, like kind of going into an industry job out of academia? Like, I feel like that's a hard adjustment for some people, but it sounded like you really enjoyed it.
I did. I think one of the biggest changes for me, I know a lot of people talk about sort of the pace of work, that the pace of academia is much, much slower. And if you've ever been in industry or academia trying to collaborate across those fields, it can be a little challenging. But for me, I think a bigger change was that the North Star of what success looked like would really change very dramatically. So Kaggle was a startup that was acquired by Google, and it has still sort of a startup mentality of iterating fairly quickly. So when I first started, my focus was really on trying to increase the number of data sets on the dataset platform, and we found that eventually that was sort of happening organically. And then my focus changed to helping people write notebooks, Kaggle notebooks, using the hosted platform, and then to just sort of growing the community and helping them grow their skills. Whereas in academia, you need to publish to top-tier conferences and journals, I guess show up for the class you're teaching. They would prefer that. It's not, teaching effort isn't really rewarded for most tenure tech jobs. And you know that in order to continue to advance, you need to have the highest number of high quality publications possible, basically. So that North Star of what success will look like for you in academia is very, very static. And in industry, at least in my experience, it has been much more variable. I wouldn't call it a North Star. I'd call it like a comet in that it's sort of moving and shifting.
Yeah, right.
A planet. It's a planet you're trying to follow.
Like a North planet. So was that like a frustrating thing, or were there good parts of that?
Yeah, I was going to say I like change. I don't think that that's like categorically true. But I enjoyed the challenge of things changing relatively quickly, and it made things feel very fresh and attainable to me. And also the goalposts were much, much closer. So, you can be working on a single research paper for years and years and years and years, whereas a project that's a long-term project in an industry setting would be like a quarter. That would be like a big ask. At least, again, in my experience, it might be different in different companies, but that's what I've discovered.
What were the kind of goals of Kaggle? Was it to sort of increase the engagement of the users then? Like you want more data sets, but like what do you think like are sort of the big goals there? Like I know Kaggle really helps a lot of people kind of get into machine learning, and they've made, so many kind of open data sets, and the kernel stuff is so cool with the collaboration. Like how do you think about that? Or what were the big kind of goals, I guess?
Yeah, I think the big goal of Kaggle is to really help all data scientists with their work. And I'm not the company anymore, so I don't really know sort of the near-term goals at the moment. But sort of all of the different things that Kaggle is doing are in service of that higher goal to help people basically get better at their job and then do their job successfully. So that definitely includes like people who are brand new to the field, sort of starting to try it out and get their first steps, and also people who are really advanced in the field and want a challenge, because certainly as most professional data scientists, machine learning engineers know, you don't spend most of your time building a model. That's a fairly small slice of the data science workflow, but I think it is for many people what drew them to data science and machine learning in the first place. So having a place where you can go and just have the part of the task that you really like doing in a very challenging way, I think is really appealing to people. Practically XGBoost or some sort of gradient boosted model will work for most things. It's fast, it's cheap to run, like probably that's what you're going to be doing day to day. And you don't really need to, get much fancier. So having a place to let go and cut loose is nice as well.
Cool. You've been at Rasa for about a month, you said?
Yeah, I guess coming up on 2 months. Yeah.
Cool. And so what does Rasa do?
So Rasa is a startup that has an open source conversational AI framework. So basically to take in text in a conversation, figure out the information that is in that text, decide what to do next, and then take that action, whether that's a turn, whether that's running some code. And then on top of that open source framework, there is a free platform called Rasa X. And Rasa X lets you deploy models, have people test your models, annotate data, and sort of fold them back in, so you have a little bit more of a human in the loop learning process while you're iterating. And then if you are a business that wanted to use these tools, we have Rasa Enterprise, which has lots of additional features.
And this is focused around kind of conversational?
Yes. Yeah. So chatbots, virtual assistants, anything where you would be interacting with an automated system through a text conversation or voice conversation rather than through a GUI or a command line.
What makes you excited about conversational? Like what's sort of the promise of conversational AI?
So I think we've all had probably bad experiences with chatbots in the past. There was definitely a period in the last couple of years when people were very excited to try the technology. And I think the sort of industry-wide design expertise wasn't there yet. So there were lots of, I had frustrating experiences. I think there's a study that like 54% of people have had just like a bad chatbot experience. But as design has really matured, I think it opens up being able to do computational tasks to a much wider variety of people. So
tasks? Sorry, what do you mean?
Or computational tasks. So anything where you need to use a computer.
Oh, I see.
Mm-hmm. So as an example, people who aren't literate have sort of limited ability to use GUIs and sort of have to memorize where things are, but probably have had conversations in the past and can, especially with voice technology, really interact very naturally with whatever computational system they're interacting with. And even just thinking of computer literacy, using a mouse is not, I mean, if you're a technologist, it's second nature to you, but it's a learned skill. It takes a while to acquire. So being able to provide services and open up access to people with a variety of different abilities and backgrounds, I think is, to me, the most appealing part of conversational AI. But also it comes with the second challenge that people who are using conversational AI come in knowing how conversations work and will always judge a conversational system against a human. Right. Because that's, this conversation is, high quality. If I were having this with a bot, my mind would be blown. I don't think that's necessarily where we're at quite yet. So being able to achieve that really fluent level of conversational interaction is a really large engineering challenge and a really large machine learning challenge. And I am really excited to be working on it.
Do you have like an example today of a kind of a conversational thing that you can actually interact with that's like a really good experience that sort of like you would point to as like that's like how things should go?
I think the most recent one that I had that was really fantastic was, actually I don't think it's publicly available, but it was for booking time off. So I knew the dates that I went into my vacation. I knew that if I was going to go through the website, I'd have to do like 80 different things. I wasn't really sure how the process works. I'd never done it before. And a coworker of mine was like, hey, use this bot. And it was a really fantastic experience. It was really well designed. So in turns where there were very few possible options, instead of having me just like generate text, it had buttons. So using buttons in that conversational flow made it feel much faster. And the whole process was, there was sort of like a variety of different things that needed to happen. It kept track of sort of the things that I'd said before. So like the dates and the things that I needed. And at the end, it took maybe 2 minutes to do what otherwise would have taken me a good half hour. So in general, I think a good conversational interaction is one where it is faster to do the thing that you need to do than it would be otherwise.
And you think like things are getting to that point now where it actually is fast? It sounds like your experience was that it was a lot faster to go through the conversational interface.
Yeah. I think it's a young field. We're definitely, we as conversational AI people are definitely learning what makes these systems work very well and be very delightful. But yeah, I think we're getting there.
I guess I have this feeling that like NLP has made some huge improvements in the last year or two. Is that sort of like, are these things like already sort of deployed in conversational agents, or is there kind of more work to do to make them actually like production ready?
Yeah. So we at Rasa have recently added an option for BERT embeddings, which I think is probably one of the things you're thinking of. But definitely transformer architectures are there. We use them, and of course we're open source. So if you wanted to use something else, you'd be welcome to. But we use contextual embeddings, specifically conversationally trained contextual embeddings. So if you wanted to use BERT instead, you would definitely be welcome to. And that paper was last year, 2 years ago, so fairly recent. A lot of the more recent work that I think has been a little bit more headline grabby has been around natural language generation. So the GPT-2 stuff, Mina, which is a Google project that came out relatively recently. And I think natural language generation is much trickier to get right. So the sort of the default setup, certainly for Rasa, is that you have a limited number of utterances that your bot can say. You might have some slot fillings. You might say, hello, Lucas, I see that you recently went to Vienna. I don't know if you've ever been to Vienna. Do you want to rate your hotel, or whatever it is that your interaction is? The tricky thing about a lot of the natural language generation is that it sounds very fluent, right? It sounds like something a human conceivably could say, which is very exciting and no small feat, but it's not grounded. So like the GPT to text examples, if you look through them, there was one where like, oh, these scientists discovered unicorns. Scientists have not discovered unicorns. It doesn't have ties to any sort of knowledge base that is the ground truth that the text is being generated around. And I think my worry is that especially people without a deeper understanding of NLP will see these very fluent text productions and be like, oh, I don't have to build a bot. I can just sort of like pipe the user input into this predictor that will come up with some sort of text that I should say back. And there's nothing to stop it from being completely infactual, from being like, yes, of course, we'll give you a full refund on your house. There's nothing to stop it from being abusive. Most of the large language models, there are certain sort of adversarial tags that you can use, like small text strings, like 10 to 12 characters, that will cause it to produce really vile, abusive output. And that's obviously not something you want to be showing to people, hopefully, obviously. So let me put it this way. I would not be comfortable doing a completely neural natural language generation conversational assistant. I definitely would want to have more control over utterances.
So the way Rasa works is it figures out an intention, is that right? And then it sort of fills in sort of like slots. Is that right?
Yeah, so that's sort of the current approach is to do entity extraction and then intention identification, so intents, where you have a set number of intents that you've provided training data for. Going forward, we're combining intents and entities together. So instead of having intent extraction as a single part of the pipeline, making it a little bit more tied in to the rest of the NLU that's going on, which is a research that we're working on.
Can you talk about kind of what you think is like hard about making a chatbot work? Like what are like the kind of core technical challenges to make one and deploy it?
Yeah, I mean, the first hurdle is the first hurdle you'll get with any machine learning project, which is getting the data. There's a sort of an older school approach, which is to build a state machine where you have like, okay, the person said hi, we're going to say hi. The person wants to know how to rent a car, or the person wants to know how to find the dealership. So we're going to go down that path. Okay, they wanted a car. What type of car did they want? So it's sort of like a decision tree, but for a dialogue agent.
Sure.
And one of the big challenges is if people are like, okay, I want a car. Actually, where's the dealership? Being able to recover from someone sort of interleaving other types of intents into your happy path that you've constructed is fairly challenging for that sort of state machine based approach. So one thing that we've done at Rasa is we have an attention model, attention with an A, sorry, not I, an attention model. So instead of having just like a straight through the tree, you'll start with sample stories, so dialogues that someone might have, and then when it comes to pick the next turn. If you have an exact example of the specific conversational flow that you've seen before, you're just going to continue on that flow because you've seen it before, you're pretty sure it's right. If you aren't sure what the intention or the entities or any of the required information is, then you'll have a fallback where you're like, could you rephrase that? Or I'm not entirely sure what you were asking for, but here's the next two closest results, or that sort of thing. And then also a machine learning based policy that ranks the possible responses and says, okay, I think this one's probably the correct next one. And then those are all considered. And if there's one that's highly likely, then that's the one that you go with. And if there isn't, then you go back to the fallback policy. So it can handle these sort of interleaved aside type structures in conversations in a way that sort of a more rigid state machine cannot.
Wait, so can I repeat this back to you and see if I if I understood it? So it sounds like the sort of first thing is just it's like kind of like essentially like a state machine kind of rule-based system. Is that?
So yes, that's not what underlies Rasa, but that's a very common approach to building conversational assistants.
No, sorry. So what's the first Rasa approach that you said?
So we have a variety of policies that are all considered together, and then the one that has the highest confidence is usually the one that's selected.
And what is a policy? Would that be like a rule, or would that be like a?
So it's more probabilistic. It's selecting you can think of it as multi-class classification across all of the possible responses. And then it'll select the one that's most likely based on the training data.
I see. And so the training data would be like an utterance or like would it be like a conversation and the intent or?
So Two types of training data. One are examples intents and an example entity. So things that the user would say. And these you might just sit there and come up with. You might collect them from maybe FAQs that you've gotten. So that's more on the NLU side. And on the other side, to determine the dialogue policy, what gets said next, you'll have examples of conversations. So you'll probably have the one that's like, okay, this is the ideal. The person says hi. They want to know what car to do. I'm going to like query the database and get the available cars and then tell them the available cars and all of that. And then you might have other turns, like other possible stories, like someone's like, hey, are you a bot? And you're like, yeah, I'm a bot. And it's like, I want to talk to a human or whatever. And then it helps them out with the thing that they need. And then those stories and those example utterances together are used to train the model. And you don't need that much. If you are using a language for which we have pre-trained embeddings, you don't need that much data to get started. And the idea is you build a minimally viable assistant, and then you deploy it and you have people make test conversations with it. Make test conversations, have test conversations with it. You go back, you annotate those, you put those back into the training data, you retrain, and you continue on in that way. So you could add additional stories, you could add new intents, you could add new utterances, you can sort of change your model to fit the actual conversations that you see.
I see. How much training data do you think you need before you get something reasonable?
So for some of the examples that I've worked on, you'll probably need 10 to 20 examples per intent, and then maybe 3 or 4 stories.
I see.
Again, because we're using pre-trained embedding, so you know that like I want a car and I want a vehicle are going to be similar because the embeddings for car and vehicle are similar. So you have the sort of the fuzziness of machine learning to help you out with that.
Maybe like shifting gears a little bit, I know that you write a lot about papers that you've read. And I think like a really common question I get is kind of like, how do I kind of approach papers? How do I find like what papers to read? How do I even like, kind of go about like reading a paper? I would think you'd have some smart advice on that.
Yeah. So don't go to archive every day. You'll just make yourself upset. I don't try to stay on top of things right after they're written. So how I will come to know that there's a paper that I want to read is I'm very active on Twitter, as you mentioned. So if a lot of people are talking about a specific paper, either as they like it or they are not a fan of it, either way, I will, once I have enough people that I trust, be like, hey, this is an important paper for one reason or another. I'll set aside time to read it. And my usual approach to reading it, first of all, if it's a really seminal paper like the Transformer paper, oftentimes there will be a blog or a talk that someone has done, and you can read that instead of the paper and get the same information. If there isn't, I would start by reading the abstract, and then I like to read the introduction and then the conclusion, so I have like a good general idea of what's going on with the paper. And then after that, starting from the top, in the related work section or the literature review section, sometimes it's at the end, I wouldn't go and chase down all of those terms that might be new to you right away. So just sort of skim that section, go to the methods. And if you see terms there that are repeated that you saw previously and they look like they're going to be used a lot in the paper, then go and look those up if you're not familiar with them. And when you get to math, so when you get to an equation, my strategy is always to try and take that and put it into human words, like the way that I would say it. And in the process of doing that, I'm usually like, oh, I don't actually know what this term is. Can I figure out what this term is from other places in the text? And that, for me, that's the part that takes the longest in reading the paper, which I think is true for most people, unless it's very similar to a field you already work in and you're very familiar with sort of the bones of the equation. And then from there, continuing through, I always skim the results because it's usually like, oh, look, here's our results. Here's other people's results. We got state of the art, huzzah. Unless there's something very specific that you're interested in. And then I will pay more attention to the ablation results if they have any ablations. So ablations are when you have a full model and you start to take parts out of it and you see what changes what. So I find those to be, particularly if you're a practitioner, if you're thinking, oh, maybe I want to implement this, but that's a lot of layers. Maybe I want a couple fewer layers. Figuring out what you can get rid of that may be practical in an academic setting, but not in a production setting is really helpful. If the paper is on OpenSoft, I know ICLR is there's a subset of conferences where the reviews are made public. So it might be helpful for you to go back and also read the reviews of the paper. If it's, again, something you're like, do I want to put this into reduction? What are other people saying? So the more you care about the paper, the further down that list you will go. The more you're like, I just sort of kind of want to know what's going on, the nearer the top of the list I will start.
Gotcha. What's a paper that you've gone like pretty deep on recently?
I'm like probably 50% of the way through the list for the convert paper, which I mentioned earlier. So that is a paper that we have implemented into Rasa. And that is Henderson et al. 2019. It's a transformer embedding architecture specifically for conversational data, which is obviously very relevant to us.
Cool. I was looking at your papers from grad school, and I saw you had a bunch of papers on kind of like Twitter and gender and things like that. And I remember being super interested in that. And earlier in my career, I'm kind of curious. Do you have any like favorite paper, any favorite result that you wanted to talk about?
Oh, from my work? So I think the result that I would most like to let people know about. So I got a lot of sort of traction with my paper that was looking at automatic speech recognition and accuracy across different demographic groups. And I had two papers, one at EACL and then one at Interspeech. EACL is an NLP conference, Interspeech is a speech conference. And the ACL paper was on gender and region, and I found differences for both of them, but that was using user-uploaded YouTube videos. And again, I was guessing at gender in a not particularly, I would say, ecologically valid way. So maybe not the absolute best methodology. But when I repeated the experiment with additional APIs and using higher quality audio where the signal to noise ratio had been controlled, so basically recorded in a quiet environment with a high quality microphone, I found that the gender differences disappeared. And for this one, I did have self-reported gender from users. The demographic regional differences were still there. And this time I also had access to race and ethnicity data, and I found a really strong difference. So when signal to noise ratio is controlled, you don't have, or at least I didn't find that the gender difference obtained, but there was a really strong difference in accuracy from people of different geographic regions. So the sort of general American prestige, educated upper middle class dialect had the best recognition rates. Any other regional dialect had lower recognition rates.
Is that thought of as its own dialect?
It's interesting because in England, there is like a very specific pronunciation set of rules that are considered the standard received pronunciation in RP, and anything else is considered a regional dialect. In the United States, you can have quite a bit of variation in pronunciation and still be considered a general American speaker. And it seems to be more around lexical items and grammatical features that make you sound not accented. Everybody has an accent. So I would say it's a variety. I would say it's less internally consistent of a dialect than a lot of other dialects, like California English, for example.
It sounds like you basically found that I guess this makes sense, that the quality got worse with any variation from kind of the standard, or what did you call it? The
General American, Standard American English, you'll hear those terms a lot. So sort of the variety where speakers are consciously avoiding using regional forms. So both in region, but also African American speakers had much higher error rates, and that's not due to African American English being any less internally consistent or easy to recognize. It's almost certainly due to imbalances in the training data. So your classic imbalanced class problem.
Right. And so did you have recommendations on how to deal with this, or?
Yeah.
Do you have recommendations?
So the gender thing is real. There is a gender difference, but it's more on the signal processing side and less on the automatic speech recognition, sort of machine learning modeling side.
Wait, what do you mean? On the signal processing side?
Yeah, so a couple of things. So one is that women in general tend to be slightly smaller, tend to have slightly lower lung capacity, tend to be slightly quieter. So for an equal decibel level of noise, you'll tend to have a little bit less signal. Also, when we were developing sort of telephony and recording in general, the band that was picked to be sort of the target band for the frequency band that was picked to be the target band for all systems, basically, and that a lot of the speech recognition comes directly from, Bell Labs and a lot of the telephone work in earlier days, was picked to suit a male voice and not any of the other types of voices you might encounter. So children also tend to have really high error recognition rates. Partially that's due to children varying more as they're learning the language, but partially that's just due to their frequency range not being represented as well.
But I guess downstream, then it actually the error rate is higher.
Mm-hmm. So definitely the regional and racial differences are due to things that you could fix with machine learning, whereas I think the other differences are not due to that.
How were you able to pull that apart?
I believe I had fairly balanced classes. Specifically on the modeling side, I used mixed effects models. So you can control for some feature as well, identifying the effects of others.
What do you think is an underrated aspect of machine learning that you think people should pay more attention to?
Data visualization.
Oh, cool.
I've seen a lot of really excellent machine learning engineers who have a hard time communicating their results and models because their charts are just unreadable.
Does anything come to mind where you like saw a really good visualization or like something you want to call out as like a excellent?
So if you want to see like some master classes in visualization, the pudding, which is actually
totally.
Journalist thing. What would you call that?
Data
journalism.
Yeah.
So it's a data journalism web magazine, I guess, has really, really stunning visualizations that just sort of push the limit of the art. So data visualization. One of my biggest pet peeves is you should not use lines to connect points unless there's a logical reason to do it. Like it's a time series or like that something could exist in the space between the 2 points. Don't do it for categories. It drives me nuts. Up the wall.
Wild question. How do you feel about 3D visualizations?
Are you in AR? Are you presenting them in a way that people can like walk around them? Like I'm not against them in general. I just find them harder to parse. And I mean, there's a whole field of study that specifically looks at how humans process information and what is most useful for conveying different types of information visually. Please read any visualization papers, y'all. Please.
What do you think is the biggest challenge for making machine learning work in the real world right now?
It's not really a technical challenge, but I think the biggest thing that trips people up is deciding to build things that don't need to or shouldn't exist. I understand it is a very exciting time to be in machine learning. We all want to work on fun projects and change the world. But particularly if you are building anything that would deal with a sensitive or a vulnerable community, I would highly encourage you to reach out to people from that community and work with them and make sure that it's something that does need to exist and that you are building it in such a way that it's actually useful. So an example that comes to mind is there have been a number of projects built by people who are not deaf and who are not signers to help deaf people communicate. And usually they take the form of gloves or computer vision to take sign language and turn it into a different language. That's not usually the problem in speaking deaf communication situations. Usually it's that the speaking person does not have a very good way of communicating their intent. In general, deaf people are masterful communicators and do not struggle with getting themselves understood. So that's just an example of like, I get it. I understand that it's an exciting project and you are very passionate about it. But before you spend a lot of time and money and resources building something, make sure people want it.
Good advice. Makes sense to me. Cool. I think that might be a nice place to to wrap up, Rachel, thanks so much for your time. I really appreciate it.
Yeah,
It was a
thank
real
you
pleasure to talk to you.
for having me.
All right, that was such a great conversation. Thanks, Lucas and Rachel. I'm gonna drop Rachel's Twitter account and some other links in the show notes below. I highly recommend that you guys check her out. She does these really cool live streams on NLP that are really worth watching. Also, before we go, I'd love to tell you guys about how weights and biases can help you get to the Kaggle leaderboard faster. So, Weights and Biases is an experiment tracking and hyperparameter optimization platform. So, what we let you do is track the performance of your models in real time. So, you can try different experiments, try different model architectures, try different hyperparameter values, and see how your models are doing in real time. We also let you log the outputs, the predictions of your models. So if you're working with images, videos, audios, or you can see here we're logging protein structures, you can actually see how your model is performing at every epoch and be able to debug it really easily. We also let you see how your model is using its resources. So you can see the GPU memory usage and all that kind of stuff. And you can compare, for instance, the effect of different batch sizes on GPU usage. You can also run hyperparameter sweeps very easily. So for example, you can pass a dictionary with a range of different hyperparameter values that you'd like us to try, and we'll automatically run all of those different models for you and show you which of those hyperparameter values did the best. We also, with this hyperparameter importance plot, we show you which of the hyperparameters were the most important and how their values were correlated to the metric that you care about. Finally, integrating weights and biases with your models is very simple. You just import weights and biases, you initialize a project, and then you can start logging any metrics that you want. We also have integrations for Keras, Scikit, LightGBM, XGBoost, and many other different kinds of models. And if you want to get started really quickly, we'll link this page down below and you can get started with weights and biases in 5 minutes. And that's all I have for you guys for today. We'll see you guys next week with another great episode.